Welcome to this video. In this session, we will be learning speed control of separately excited DC motor using chopper circuit. So this is the power circuit. So it consists of the rectifier with filter element, which is going to provide the DC voltage of 220 volt to the circuit. We provide 220 volt AC, but rectifier is going to provide the 220 volt DC. And in this power circuit, there is a one MOSFET, diode, and load armature, which is nothing but an inductive load in nature. So there are two modes of operation. The first mode is when the MOSFET is turned on by giving the pulse to the G and S, then power flows from the source through MOSFET drain and source to the motor and return path in this direction. And when the MOSFET is turned off, whatever the energy available in the coil of the armature will be freewheeled through the diode. So this process continues every time. And this is the armature method of speed control. So we are going to vary the DC voltage fed to the armature. But for the field coil, we give the constant DC voltage from the rectifier circuit such that the field current remains same. So this is basically by flux is constant, we are varying only armature voltage. So we are not weakening the flux. So here we can vary the voltage such a way that we can vary the speed from the 0 to rated speed. If you want the speed more than rated speed, then obviously we go for the field weakening method. But this method is suitable for the armature method of speed control. Now let us see how to generate the pulses. We are generating the pulses using the IC 7G3524. This is a regulating pulse width modulator IC. And here we have both frequency adjustment and the PWM control. Now initially what we do, we set the pulse time period T to 10 millisecond. So inverse of 10 millisecond is nothing but 100 Hertz. So we set the pulse at 100 Hertz. So thereafter we are not going to vary the time period. We vary only the on time of the pulses by varying the pulse width modulation or a PWM control. So let us see the module PEC08. This is a module PEC08. You can observe PEC08 is a module for MOSFET chopper control. This is the SG3524. And you can see there are two knobs, frequency adjustment and the PWM control. And the only wire you have to connect is this wire you have to connect it, as well as 12 volt has to be given, DC volt has to be given from the VRPS. From the VRPS. Let us see the waveform. So initially we have to set the frequency to 50 Hertz. Let us measure the frequency. You can see the amplitude is varying, on time is varying. Whatever the voltage we have here is around, let us put it in ground. And put this in DC, not in AC mode. If you put in AC, it will come down. Put it in DC mode. And you are getting the frequency here. So 1, 2, 3, 4, 5. 5 units total time period into 2 millisecond in the knob. So it is a 10 millisecond. Inverse of 10 millisecond is 100 Hertz. So we set the frequency 100 Hertz. Now I am going to vary the pulses. I am reducing the on time now, so that duty ratio also going to reduce. Now let us increase the on time. We are increasing on time, but we are not varying the total time period. It remains same for the entire operation. The total time remains same for the entire operation. So these pulses are fed to the gate terminal of the MOSFET. Now here we have the DC power supply. Is a rectifier circuit. There are two supplies are there. One is a field voltage 220 volt DC. So and another one is armature voltage 220. We give this armature voltage through the chopper circuit. Variable DC voltage is fed to the armature voltage of the motor. This is the DC motor, DC shunt motor power module. For field terminals, we connect the wires from the rectifier power supply. Plus connection, plus is given to the plus itself, and minus connection is given to the minus. We are not going to vary the field voltage. Only armature voltage we are going to vary from the rectifier. Rectifier is going to give the constant DC voltage that is fed to the your chopper circuit. So we have a chopper MOSFET, diode, and then the additional connections are such a way that we take the plus connection of the armature to the switch. Here we are using the IGBT, we can use IGBT or MOSFET. Then from the your emitter point, collector and emitter point is given to the diode. You can see the diode connection here, diode point, and from the same emitter point, the fuse wire is connected. Fuse another wire is going to the your armature plus, and armature minus is connected to the diode another point, that is a negative terminal, and the negative terminal of the rectifier is connected to the negative terminal of the your 220 volt armature point. So these are the connections. Let us start to conduct the experiment. So let us turn on the regulated power supply. Now the pulse is not zero time being. Let us vary the PWM of the pulses. It's increasing slowly. So one wire has come out. Let me connect it. ರನ್ ಆಗ್ತಿದೆಯಾ? ಓಕೆ, ರನ್ ಆಗ್ತಾ ಇದೆ. Let us note on the on time. It's showing a 0.6, the three subdivisions, 0.6 unit into 2 milli. That is 1.2 milli is the on time. Total time remains same as a 10 milli. That is 1, 2, 3, 4, 5. 5 to the 10 milli remains same. Only on time is 0.6 into 2. That is 1.2 milli. So 1.2 milli by 10 is 0.12 is the duty ratio. Let me remove the CRO connection here. Then turn on the rectifier. When you turn on the rectifier, the speed is showing 190 RPM, 190, and voltage, DC voltage is 22.9. 22.9, slightly fluctuating, but no problem. You can take one of the value 22.9. Let us go to the duty ratio 0.4. For that, turn off the rectifier, connect the CRO, and set it to 1 unit. So 1 unit into 2 is a 2 milliseconds. 2 millisecond by 10 is 0.2. Now remove the CRO connection, then you turn on the rectifier. Let us see the speed. Speed is 418 RPM. Voltage is you can take 47. Then again turn on the rectifier. Let us go for a 2 units, that is 4 milliseconds. So let me set it to 2 units. 2 units by 10 is, sorry, 2 into 2 milli, 4 millisecond. 4 millisecond by 10 is 0.4. Remove the CRO connection, turn on the rectifier. So speed will increase gradually. It's showing 666, and then voltage is 74. You can take 70. Small fluctuation will be there because of the armature voltage. So 74 volts you can take. Again, let us set these to Let us set this to 3 units. So it's nearly 3 units. So nearly 3 units is there. Now we check the voltage. We remove the CRO connection and then turn on the supply. The speed has increased to 769 RPM and the voltage is increased to 84.4. And let us see the last reading. Current back the CRO. Current back the CRO. And let me go for highest duty ratio possible. So my on time is almost equal to total time period here. So we can take 4. Let us go for a 4 units into 2. That is 8 milliseconds. 8 milliseconds. And then turn on the rectifier. Our speed will increase to 809. And voltage is 88.5. So it is enough to go up to 80% duty ratio, and by varying the duty ratio we could able to vary the speed of the motor as DC voltage is going to vary. So we have the formula that V0 is equal to duty ratio times input voltage. So based on that, the output voltage will vary, frequency and the speed also vary in the motor.